Hello everybody. Hello everybody. In the previous video, we learned how to clean up our data and arrange it. And in the next video, we will do the Markov switching model. But before that, in this video, we would just do a small analysis of the routine test, like the unit root test of the dataset. And we would use the Garch and the Garch model to do a preliminary analysis of our data. Okay. So here in Excel, in eViews, I have brought my IT return and my Sensex return series. So like for the sake of better understanding, I would show how to bring that data set here. So I would delete this data set. So we go to File, Import, Import from File. From Downloads, we had yeah. So here we have date, then the IT return and the Sensex return series. Okay. Uh, so firstly, let us take the Sensex return series, or we can take the IT return series also, and do a descriptive statistics analysis. So as you can see here, like the we have the descriptive stat. So skewness, it is negatively skewed, which shows that it is slightly negative returns are more than positive returns. Kurtosis is significantly greater than 3. The Jark Better test for normality shows us that the series is not normal. The p value is 0.000, which shows that the null hypothesis is rejected, that the series is not normal. We know from our understanding of theory that a return series would obviously be a stationary series. However, we can also check it. So we do a unit root test, where the null hypothesis is that the series is not stationary, that the series has a unit root. So you see that the p-value is 0.00001, which means that the null hypothesis is rejected here, which shows that the series is stationary. Let us now try to do. Uh, Let us now try to do a eGarch model. So we would do it with the IT return series. So the error distribution, we can do it students t, and also we can do generalized error distribution. Students t doesn't give us that accurate results, so it is better to do generalized error distribution. However, you can do it on the basis of your research question. Okay. So we would change this to eGarch. Let us do eGarch first, then we would do a component arch. So eGarch shows us if there is any asymmetry in the dataset. It shows us that whether the dataset behaves in a different way during negative shocks and positive shocks. That is, whether during period of negative market conditions or negative conditions of the sector, whether the volatility is more or whether the volatility is more during positive market conditions. We can analyze that on the basis of eGarch. Here we have the results. So let us understand it on the basis of theory. Okay. So we have the eGarch model equation here. The C5 term basically shows us the asymmetric effect or the leverage effect of past shocks on volatility. So as we can see here, the C5 term is negative. It is less than 0, which shows that negative shocks or bad news increase volatility more than positive shocks or good news. And Also, like the C6 term, it shows us how much past volatility, that is Garch T minus 1, past volatility is affected by present volatility, that is Garch T. T means this time period. It is 0.960, which shows that it is like close to 1 but not 1, which shows that there is persistence for a short period. However, it does wear out over time. So it is close to 1, which means it is highly persistent. So now we will do component arch model estimation. So component arch shows us if there is like component arch shows us if there is any impact of permanent shock, or the impact of short term or transitory shocks are more. We can analyze that on the basis of component arch. So here we have it. Let us understand it on the basis of theory. So we have a long-term component and a short-term component. The long-term component is given by the first equation here on EVUs. So Q equals to C3 plus C4 into Q minus 1 minus C3 plus C5 into residual square minus 1, which means the past period, minus Garch minus 1, which is here, this equation, the long-term component equation. And the short-term component equation is given in EVUs by this equation, Garch equals to Q plus C6 into residual square minus 1 minus Q minus 1, this one. So Q shows the long-term volatility component at time t, and the short-term component, we can understand it from the Garch equation. So let us now analyze how the results have been given here. So, if we like match it with what is given in theory, then we can see that like the rho component, which is the parameter of showing the persistence of the long-term component, it is given here by C residence minus 1. Yeah, it is given here by 1 minute. Yeah, it is given here by C5. Okay, because C5 is the equation which, okay, sorry, it is, sorry, not C5, it is given here by C4. It is given here by C4 because like I have highlighted it also. Like C4 here, it is C4 like Q equals to C3, which is the average long-term average volatility, the constant term, plus C4 into Q minus 1 minus C3. Here it is W plus rho into QT minus 1 minus W. So C3 here is W and QT minus 1 is Q. Here it is given by Q bracketed minus 1, which is QT minus 1, and the rho component is given by C4. So let's see. C4 is 0.962. This shows that there is a long-term persistence of the permanent component of volatility, the long-term component of the volatility, uh, which is not a very good indicator. However, it is not equal to 1, which means that the permanent component does die down over a long time. However, it is very close to 1. The rho component, which is C4, it is very close to 1. Okay. We can also plot this data set. So we can plotted by this. We can write the conditional variance as CV and the permanent variance as PV. So total volatility, which is given by this conditional variance, which is showing here, this total conditional variance is actually the addition of the permanent component as well as the transitory component of the volatility series. So here we have it. Let us do a graph and understand. Okay. So, as we can see that the permanent component was quite high during the COVID-19 periods, and it took a long time to die down. So, like the permanent component is given by the red. So, it took a long term to die down, and it covers a huge portion, a very significant portion of the total conditional volatility. We can actually also see, wait, no, not here, sorry. Wait, we can also actually see on the basis, like we can in a graph we can see three things together also, like we can see the transitory component, the permanent component, and the total conditional variance in one graph also. I'm trying to show you that. Yeah, so from this we can see that like we can see the three things together. So we can see that the permanent component is given by the red line and the transitory component is given by the green line. So we can say that the transitory component are more detailed than the permanent component. However, the permanent component also covered a huge portion of the total variance during the crisis periods, which is in 2020 financial crisis during the COVID-19 times. And after that, the permanent component took a long time to die down. So we can do more detailed analysis also of this. However, here we end our analysis of Garch and um, eGarch. And in the next video, we would do Markov regime switching model. Thank you so much.